In this video, we are going to discuss about the preparation of alkenes and alkynes. So first, let's see the preparation of alkenes. Now the first method is from alkynes. So the first method for the preparation of alkenes is from alkynes. That is, alkyne is triple bond. We are converting it into double bond. So the method is by treatment with hydrogen in presence of finely divided catalysts like platinum, palladium, nickel. The triple bond breaks and we get double bonded alkene as the product. So I am going to show one example for this. Example, CH triple bond CH plus hydrogen in presence of catalyst platinum. The triple bond, triple bond breaks and we get H2, one hydrogen adding to double bonded carbon and the second hydrogen adds to the next double bonded carbon. We get the product as CH2 double bond CH2. So this is the first method. Now the second method for the preparation of alkene is from haloalkanes. Second method, from haloalkanes. Haloalkanes is the IUPAC name. Common name is alkyl halides. And from haloalkanes, we do beta elimination reactions to prepare alkene. Now let's see how to prepare alkene from haloalkanes. Haloalkane on heating with alcoholic potash. So the reagent used is alcoholic potash. That is KOH, potassium hydroxide. That is alcoholic potash, or you can write alcoholic KOH. Eliminate one molecule of hydrogen halide to form alkene. And this reaction can also be called as dehydrohalogenation reaction. Now from the name, dehydrohalogenation means minus HX. So what do you mean by dehydrohalogenation reaction? That is the removal of a molecule of hydrogen halide from haloalkane to form alkene is called dehydrohalogenation reaction. And what is the reagent used here in dehydrohalogenation of haloalkane? It is alcoholic KOH. You get alkene as the product. And I told you this involves beta elimination reaction. So we are going to write example for this method. Example is, first example, CH3 CH2 Br, bromoethane plus alcoholic KOH. Heat. Now we know that this is alpha carbon, that is the halogen or functional group attached carbon is alpha and the carbon attached to alpha carbon is beta carbon. Now from here HX is removed, means Br, and from beta carbon one hydrogen is removed as H+. So this hydrogen is removed. Now what will be the product on removing one hydrogen from CH3? We get CH2. The single bond becomes double bond and we have CH2. Now this H will combine with OH minus to form H2O. So the byproduct is H2O plus K plus will combine with Br minus to form KBr. So these are the byproducts. Now this is an example for beta elimination reaction. Also this is a dehydrohalogenation reaction because there is removal of hydrogen halide. Now I'll give you one more example. Example 2. That is CH3 CH2 CH2 Br plus alcoholic KOH. Heat. Now here we have alpha carbon and this is beta carbon. So from alpha carbon halogen is removed, beta carbon one hydrogen is removed. So this H plus combined with OH minus and Br minus combined with K plus. And what is the product form? The product formed is alkene, that is CH3 CH double bond CH2, that is propene, plus byproducts are KBr plus H2O. So these are the examples for preparation of alkene from haloalkene, that is beta elimination reaction, or this is a dehydrohalogenation reaction. Okay. Now in both these examples you can see we have only one beta hydrogen or one beta carbon present. So if there is only one beta carbon present, we get one alkene as the product. Only one alkene is obtained as the product if there is only one beta carbon present. Suppose there are two beta carbon atoms present, means on either side of carbon carrying halogen, suppose we have two carbon atom, then we can call it beta carbon. In that case we get two different products, because elimination can take place. Elimination of hydrogen halide can take place in two different ways. So here we have something called Zaitsev rule to study. And Zaitsev rule, when do we apply this Zaitsev rule? If there are two beta hydrogen atom on either side of carbon carrying halogen, in that case elimination is possible in two different ways, giving rise to two different alkenes. So we use Zaitsev rule here, that is to predict which is our or which alkene is the major product. So we are going to discuss Zaitsev rule. Zaitsev rule. Now what is Zaitsev rule? Whenever two alkenes are possible during a dehydrohalogenation reaction, it is always the more highly substituted alkene. More highly substituted alkene. Now how to find the more highly substituted alkene? That is alkene having less number of hydrogen atoms on double bond. That will be the more substituted or highly substituted alkene. That is alkene having lesser number of hydrogen atom on double bond. That will be the product that predominates. So what is Zaitsev rule? According to Zaitsev rule, whenever two alkenes are possible during a dehydrohalogenation reaction, it is always the highly substituted alkene. That is the alkene having lesser number of hydrogen atom on the double bond, which predominate as the major product. Now let's see example for this Zaitsev rule. That is, here also we are preparing alkene from haloalkane, but this haloalkane will have two beta hydrogen atoms. So two alkenes are obtained as product, and the Zaitsev rule it helps us to decide which is the major alkene that goes as the major product. So example 1, CH3, CH2, CHBr, CH3, alcoholic KOH, heat. Now let's mark the alpha and beta carbon in this. Halogen attached carbon is alpha carbon, and the carbon atoms attached to alpha carbon is beta. So you can see here we have two beta carbon. This is one beta carbon. This is the other beta carbon. Now here dehydrohalogenation is possible in two different ways. First, suppose I remove bromine, halogen is removed from alpha carbon. Hydrogen I am going to remove from beta carbon. So first I am going to remove from this beta carbon. When I remove from this beta carbon, what will be the product? The product will be CH3, CH2, CH, double bond CH2. Now, next I am going to remove the beta or hydrogen from this beta carbon. So, what will be the product? Plus CH3, hydrogen is removed from this beta carbon. Okay, So what will be the product? CH3, CH, then here we have a double bond and bromine is removed from alpha carbon. So double bond CH, CH3. Now look at the alkenes produced. The name of this alkene is 1, 2, 3, 4. This is but 1-ene and this is 1, 2, 3, 4. This is but 2-ene. Now, which will be the major product? Now, you can see here the major product will be our but 2-ene. So, this is the major product and this is the most stable product and this is the minor product and the unstable product. Now, how did you identify this as the major product? By using Satzer rule. That is, the alkene having lesser number of hydrogen on double bond. That is, if you look at this but 2-ene, you can see on either side of the double bond we have 1 plus 1, 2 hydrogen. Whereas here in but 1-ene you can see there are 2 plus 1, 3 hydrogen present. So this is but 2-ene is highly substituted alkene or it is the major product and but 1-ene is the minor product. Okay, now we will have one more example for the Satzer rule. Example number 2. Example is CH3, CH2, CH2, CHBr, CH3 plus alcoholic KOH, heat. Now, here again let's mark our alpha and beta carbon. Alpha carbon is this. Beta carbon again we have 2 beta carbon, which means we have 2 beta hydrogen. Now let's remove HBr. First H I am going to remove from this. Okay, so what will be the product? Product will be CH3, CH2, CH2, CH double bond CH2 plus. Now second alkene I am going to remove beta hydrogen from this carbon hydrogen. So what will be the product? The next product will be CH3, CH2, CH double bond CH, CH3. Now let's write the name 1, 2, 3, 4, 5. This is pent 1-ene. And this compound is 1, 2, 3, 4, 5. This is pent 2-ene. Now, to decide the major product, we have to check on Satzer rule. So, according to Satzer rule, the double bonded carbon carrying less number of hydrogen will be the major product. So, here if you look in pent 1-ene, we have 2 plus 1, 3 hydrogen. And here if you look, we have only 2 hydrogen. So, which will be the major product? Pent 2-ene is the major product. So, it write the word major under pent 2-ene. Okay, so this is our Satzer rule. This is also a method for the preparation of alkene from haloalkene. So, this is our second method for the preparation of alkene. Now, let's see the third method for the preparation of alkene, that is from vicinal dihalide. So, third method is from vicinal dihalide. Now, dihalide means there are 2 halogen atoms present. Now, what do you mean by a vicinal dihalide? Vicinal dihalide means dihalides in which 2 halogen atoms are attached to adjacent carbon atoms. They are called vicinal dihalides. For example, CH2Br, CH2Br. Here 2 halogens are attached to adjacent carbon atoms. So, you can call this a vicinal dihalide. Now, let's see how to prepare alkene from vicinal dihalides. Vicinal dihalide on treatment with zinc metal. So, here the reagent is zinc metal. Lose a molecule of zinc halide to form alkene. Now this reaction can also be called dehalogenation reaction. Dehalogenation. Dehalogenation means what? Removal of halogen atom from dihaloalkane. Now here the product again formed is an alkene. Okay, so the reagent used for dehalogenation from a vicinal dihalide is zinc metal. We get alkene as the product. So let's write the example. Example 1. CH2Br CH2Br plus zinc metal. ZnBr2 is removed. ZnBr2 is removed. So the product will be what? CH2 double bond CH2 plus zinc bromide. Now next example, example 2. CH3 CHBr CH2Br plus zinc. Now this is also a vicinal dihalide because halogen is attached to adjacent carbon atom. And how will you name this compound? You can number this as 1, 2, 3. So what is the name of the compound? 1, 2 dibromo, 3 carbon is propane plus zinc metal. Now again ZnBr2 is removed and we get alkene as the product. So what will be the product? CH3 CH double bond CH2 plus ZnBr2. Propane is the product. Okay, so this can be asked for conversion also. That is, convert 1,2-dibromopropane to propene. The reagent used is zinc metal. So this is the method of preparation of alkene from vicinal dihalides. Now the last method for the preparation of alkene, that is the fourth method, is from alcohols. So number 4, from alcohols. You know the alcohol functional group, that is OH. Now from alcohols we are doing dehydration, acidic dehydration. What's the meaning of dehydration? Dehydration means removal of water. Now let's see how to prepare alkene from alcohol. Alcohol on heating with concentrated sulfuric acid form alkene with elimination of a water molecule, and this reaction is called dehydration from alcohol. So you know that concentrated sulfuric acid is a very good dehydrating agent. It helps to remove water. So H2O is removed from alcohol, we get alkene as a product, and the reagent used is concentrated sulfuric acid. Now this is also an example for beta elimination reaction. Okay, let's see how this comes as an example. Let's write the example. CH3 CH2OH ethanol plus concentrated H2SO4 heat. Now this is our alpha carbon because the functional group attached carbon, and this is beta carbon. Now I told this is also a beta elimination reaction because OH is removed and hydrogen from CH3 is removed as H2O. So what will be the product? CH2 double bond CH2 plus H2O. Alkene is the product, and concentrated sulfuric acid is a very good dehydrating agent. Okay, so this is how you prepare alkene from alcohol, by adding concentrated sulfuric acid, or by the dehydration of alcohol we get alkene as the product. So preparation of alkenes, the 4 methods are over. Now next let us see the preparation of alkyne. So next we have preparation of alkyne. Now alkyne we have 2 methods. The first method is from calcium carbide. Calcium carbide, and calcium carbide is CaC2 formula. Now this calcium carbide is prepared by heating quicklime with coke. And quicklime is calcium oxide. And how is quicklime produced? Quicklime is produced by heating calcium carbonate, that is limestone. So I'll write the different reactions. First is the preparation of quicklime, that is calcium carbonate. This is our limestone, calcium carbonate. On heating we get quicklime, calcium oxide plus carbon dioxide gas. Now from quicklime you prepare calcium carbide, that is quicklime is calcium oxide. Now how to prepare calcium carbide from quicklime? Calcium carbide is prepared by heating quicklime with coke. So coke is carbon, coke. You get calcium carbide plus carbon monoxide. Now from this calcium carbide we prepare our alkyne. So I am going to write the preparation of alkyne from calcium carbide. The equation is CaC2 plus 2H2O. So this calcium carbide is treated with water. You get alkyne plus calcium hydroxide is obtained as the byproduct. So this is the reaction or equation for the preparation of ethine. Ethine, or this is also called acetylene. So how do you prepare ethine from calcium carbide? By treatment with water. You get ethine and calcium hydroxide by treating calcium carbide with water. So this is the method for the preparation of ethine from calcium carbide, and this two are the methods for the preparation of calcium carbide. Okay, first we prepare calcium oxide, then calcium oxide is treated with coke to form calcium carbide, and this calcium carbide when treated with water we get ethine as the product. Now the second method for the preparation of alkyne is from vicinal dihalides. Now we already saw what are vicinal dihalides. There is two halogens attached to adjacent carbon atom. Now let's see how to prepare alkynes from vicinal dihalides. Vicinal dihalides on treatment with alcoholic KOH undergo dehydrohalogenation to give an alkynyl halide. That is, vicinal halide on treatment with alcoholic KOH. You first get an alkynyl halide. From the name itself we have En. There is a double bond and halogen also. Alkynyl halide. This alkynyl halide on treatment with sodamide. Sodamide formula is NaNH2. This is sodamide. You get the final product, that is our alkyne. Okay, so how will you prepare this from vicinal dihalides? Vicinal dihalide is treated with alcoholic KOH. We get alkynyl halide, which is then treated with sodamide. You get alkyne as the product. So we are going to write the example. Example: CH2Br CH2Br plus alcoholic KOH. Now here you know that in presence of alcoholic KOH, HX, hydrogen halide, is removed. So one halogen you can remove from any carbon, one halogen from CH2 and hydrogen from the other CH2Br is removed. So HBr is removed, and what is obtained here? CH2 double bond CHBr. This is our alkynyl halide plus HBr. Now in the second step, this alkynyl halide, that is CH2 double bond CHBr plus sodamide NaNH2. Now sodamide, you know, Na has positive charge and amide NH2 has negative charge, and here we have bromine with negative charge, and Here one H will be removed as H plus. That H plus will combine with NH2 minus and you get NH3. Now Na plus will combine with Br minus to get NaBr. Finally what is left out? CH, triple bond CH. So how will you write the product? The product will be CH triple bond CH, ethyne plus NaBr plus NH3. Okay, so this is the method for the preparation of alkyne from vinyl dihalide. So with this we complete the preparation of alkenes and alkynes. Only two methods for the preparation of alkynes. One is from calcium carbide and second is from vinyl dihalide. Thank you.